Hi all, welcome to Data Structure Learning at Madanapalle Institute of Technology and Science, Data Science Department. I am K. Pugazharasi, Assistant Professor from Department of CSE Data Science, MITS. In previous lecture, we have seen discussed linked list implementation of list ADT using singly linked list. In today's session, we will discuss about how to implement that list ADT using doubly linked list. We will see how the number of operations that we can perform using doubly linked list: create, insert, delete, find, display. We will see one by one the how to perform this set of operations. As we know, list ADT is a sequential storage structure in the form of A1, A2, A3, etc. up to AN, generally a collection of elements. Okay, here if I is an AI is an element, its predecessor will be AI minus 1 and its successor will be AI plus 1. The number of operations that we can carry over on list are to check whether it is empty, or we can make an list to be empty, and to check an position whether it is the last position, and finding an element, inserting element at different positions, deleting an element from different number of positions, and moving previous to previous nodes and moving to next nodes. Okay. First, we see the definition of a doubly linked list as implementing list using linked list. We use structure called node. That node has the element and address of next node. Each node contains the address of next node. Then what's the difference between singly linked list and doubly linked list? Each node contains address of both the previous nodes and next nodes. The disadvantage of singly linked list is only we can traverse in the forward direction. The next element can be retrieved from any node. But in doubly linked list, what we are doing, each node contains data. Along with that, it contains address of both its previous node and its next node. So with the help of that previous node, we can traverse backwards from any position to till the head of list we can traverse. So this doubly linked list is used to overcome the limitations of singly linked list by moving backwards. And see the node structure. Um, Here we have each the doubly linked list represents is a collection of nodes. Here the node we are partitioning into three partitions. The first contains address of previous node, the second contains the data element, and the third contains the address of next node. So the first node's previous pointer holds null field, and the last node's next pointer holds the null remaining values. Each node contains the address of its previous node and both the address of its next node. This is the structure for creating a node using doubly linked list. Since it has three fields, the node we have defined using two pointers. First, previous pointer representing address of previous node, and element field that holds the data, and the next pointer holds the address of next node. This can be dynamically allocated using malloc function in C. This is the node structure. First holds the previous, it's a pointer holding address of previous element. This field element hold actual data is stored here, and the next pointer holds the address of next node. See how to create a doubly linked list. The same thing how we done with for a singly linked list. Only we the high changes I have highlighted here. This L represents the header beginning of the doubly linked list, and the linked list we have created here contain three elements. See how we have created. First we have initialized the list L, and two pointers we have declared P and to be temp. So for the number of elements here we have created three elements. So for n we get the give the value 3. Each time it scans a value and it allocates a memory using malloc function. In the name of temp it creates a node. Then we are storing the element x to be its in the element field, and the previous field is said to be P. Similarly, the next node is P next is temp, and temp next refers the null since each node is appended at the last. Temp next refers to null. P equal to P next. This line is to traverse at to point each time the end of list to be P. So the only change between a singly linked list and doubly linked list is that this temp previous equal to P. This line alone we are including for implementation of list ADT using doubly linked list. Only we have to make pointer adjustment for previous node. So each node's previous address should be the temp node. Okay, so the temp node is the node we have created newly. P is the previous last node. So this represents P. This node we are appending now. So how to change that? This temp node's previous field should hold the address of P. So temp previous equal to P. This line creates this backward connection. So this alone we are adding with that singly linked list implementation for creating using doubly linked list. Then next, how to insert an element at the middle of a doubly linked list. The same thing, the every line that we have seen using singly linked list, we will be making pointer adjustment for forward direction. So if this is the node P, after that we have to insert now. First we have to stretch the find the position P. Once we have retrieved P, next to it we have to insert the temp cell. So temp node we have created using malloc function. We use malloc function to allocate memory, and temp element equal to x. We store the element there, and this right side connection should be established first. So temp next equal to this node can be referred as P next. So temp next equal to P next. This right side connection is right side forward connection is established. Then for backward we are writing uh, P next is equal temp next is equal to P next. Okay, then P next is equal to temp. With that, the forward pointer will be created for next adjustment. So how to store the values for previous pointer? See, temp nodes previous should point to P, and then this next nodes P's next node is this node. This node's previous field should be temp. So this node is now temp's next. Initially this node is P next. Now once the forward connection is established, this node is retrieved using temp next. This node is temp, this is temp's next. So temp next previous should hold the address of temp. This is the line temp. Temp next is this node. This node's previous field should hold the address of temp. So this is the line temp next previous equal to temp, and then temp's previous should be P. Temp previous is P. This is temp node. Its previous field should hold the address of P node. So temp previous equal to P. These two lines we include for inserting an element at the mid of doubly linked list. Next, to how we do the changes to insert at the beginning. The same thing for temp node, we allocate memory using malloc, and we store the element temp element equal to x, and then it should be appended between next to L. L represents the header node. So temp should be now L next. So L next is temp. Then how to make temp next then will be else next. So usually when we are making pointer adjustment, first we have to write the statement for establishing connection at the right side. So temp next is equal to L next. This node can be retrieved using the name L next. So this node's address is stored in L next, that we are storing in temp next. Now this right side pointer creation is done. Then for left side adjustment, how to do this? L next will be temp, that we have done. Then the temp node's previous field should hold the address of L, that we have included one more line, temp previous equal to L. So this statement makes the uh, temp node's previous field to point to L. And then one more change we have to do. What is that? This nodes, now this node can be represented using temp next. Temp next previous field should hold the address of temp. So this line we have to insert one more line. Temp is that the node 26, that's its previous is the previous field that should hold the value of temp. Temp next previous should hold the value of temp, that we have to include. Okay, then now the backward pointer is also adjusted. This is the way to insert an element at the beginning. To insert at the last, the only thing we have to move that header node from L to the end of list. Previously the end of list is 12, the node 12 is the end of list. From here we have to move this to um, this location. So for that we are using this while loop. So while p next not equal to null, p equal to p next. So we are initially copying the value of L to p here, and till p next not equal to null, we move p equal to p next. So now p will end up here. P will end up at the position here, right? P will end up here. Then temp, using a malloc function, we allocated the temp node, and temp data is stored as 35. Then we have to insert that temp previous equal to p. This is temp, its previous we are maintaining as p, and p next is equal to temp. So with this the forward connection and backward connection both are established. Then temp next is equal to null. Okay, so these two, this temp previous equal to p line creates the previous pointer adjustment. Okay, with this we are inserting element at the last. And to perform deletion at the in between places, at any place we want to perform deletion, first we have to find the element where it is. Consider here we are passing an element x, that is the element to be deleted. So here I am passing x as 35. So first we have to find where 35 is. So with this while loop, p next element not equal to x, we are making p equal to p next. So p starts from L and it checks for the occurrence of 35. It moves forward. So it stops at the position one node previous to the actual element. So now p stops here. So we are here, we have to readjust pointer like this. So how this can be done? Now p next is temp. This is the node to be deleted. So temp equal to p next. Then p's next should be temp next. Then only this pointer will overlap, and it bypass the temp node and connects with the node next to temp. So p next is equal to temp next. This line creates this forward connection with from 26 to 12. And similarly 12's previous field should hold the address of p. So how to name 12's previous? 12 is next to, now p next is 12. So p next is previous. With the first line executed, p next is now this no, instead of temp we have assigned for this node. Now this node is called as p next. P next temp field will hold the previous field, should be assigned the address of p. So p next previous is equal to p. With this line the backward connection also established. Okay, so this is the node p. This is referred as p next. We are naming it to temp. Temp is, should be deleted. For deleting this we have to readjust connection between p and this node. This node is initially temp next. So p next is stored the address of temp next. Now this is not temp next, this is p next. So p next previous field should hold the address of p for backward connection. Okay, that also we have done. Now both the forward pointer and backward pointers are connected, that is previous and next fields are readjusted. Now we are freeing the node temp. This is the way we perform deletion at any position. Then deleting an element at the beginning. How to delete an element? The beginning will be the node that is next to L. L is the header node. The node next to L should be deleted. Uh, this node can be retrieved using L next. So temp equal to L next. We have assigned the name temp for this node. So instead of temp to be L next should be assigned the value of this node. This node is now temp next. So L next should be assigned the value temp next, that we are doing here. And then now this node is L next, right? With the execution of first line, instead of temp, the next node, that is 35, will be acting as L next. So L next previous field should hold the address of L. So L next previous, we are making it to point to L. With the first line executed, L next, instead of temp, this node will be the node next to temp, that is 35, will be assigned as L next. So now the forward connection established. L next represents the address of 35. So 35's previous field should be stored the address of L, that we are writing as the second statement. L next previous equal to L. Then later on we are freeing the memory allocated for temp. So free temp. With this we are deleting an element at the beginning. And how to delete an element at the last? Similarly, we have to traverse from the beginning of list to last position, that we are traversing using this while loop. We have traversed here, and just whether we can stop at this position or we can stop at this position. If it is singly linked list, sure we have to stop one position before the end of list, because we can't move backward. But since it is doubly linked list, whether we can stop a node previous to the last, or we can stop at the node itself. Even if we stop P at the node itself, just P's previous, if we make it as null, the last element can be freed. Okay, so uh, this is the advantage of doubly linked list, whether we can stop at one position before or we can stop at the same position. Even if we stop at the same position, we can move backward with the help of previous pointer, so it's easy to retrieve backwards. Okay, here we stop one position before, and this is the node to be deleted, that we name it as temp equal to P next, and P next field we are making is null, and we are freeing the temp cell. So very easy, no change between deleting an element, last element in the singly linked list and in doubly linked list. Either we can traverse and stop one position before or at the same node. Temp as P we can stop, right? So this is the way we are deleting an element at the last position. And how to find an element? Usually we know the beginning of list only. So from here no need of backward pointer, just with the help of forward pointer, that is with the help of next pointer alone, we can find an element. If see here, we have to find the element x that we are passing as input, and with this while loop until it is not null and its element not equal to x, we are moving p equal to p next. So this while loop get stopped when the element is found or when it reaches the null position. When it reaches null position, if an element is not existing there, it will end up with null. So at last we are returning the P, that is the address of node where that element X resides. Okay, so using this next pointer alone, we using this next pointer alone, we retrieved the element. Okay, then what's the help of backward pointer here? If at this position, if we want to find some other element, what we can do? No need to again start from the beginning. Okay, from that position, with the help of next pointer, we can move towards the end, and with the help of previous pointer we can move towards the beginning for search of that element x, okay, for search of that element y. Okay, if it is singly linked list, to find the next element again we have to start from the beginning and we have to traverse, but since we have the address of previous nodes also with the doubly linked list, from where we are now at the position where we are currently now, we can start searching in both forward and backward directions. That's the added advantage of doubly linked list, right? Then for printing or displaying the list with the help of just a forward pointer, we are printing the element. This header nodes address we are passing, and until p not equal to null, we are displaying p c element, and we are forwarding the pointer p equal to p next. It moves from p here to here until it reaches end null. It retrieves each node and prints the element present at that node and moves forward. Right. So here in this lecture, we have illustrated the implementation of list ADT using doubly linked list, and this doubly linked list is more advantageous when compared to singly linked list because of that backward traversal possible in doubly linked list. It overcomes the limitations of singly linked list. No need to find the previous location. Each node contains the address of previous node, so at any point we can move backwards or we can retrieve the element position of a node previous to it. So both forward and backward traversals are possible in doubly linked list. With this, in the next lecture we will discuss about the applications of list ADT. We have several applications that we see in the next lecture. If you have any queries, kindly leave your queries in the given form. Thank you.